Hello there, and welcome back to this quiet corner of the universe where curiosity slows down, where the night feels a little softer, and where the vastness of space becomes something gentle enough to fall asleep beside. Wherever you are right now, curled up in bed, settling into a late night break, or simply letting your mind drift after a long day, I'm glad you found your way here. Tonight, we're going to float together into one of the most subtle, silent mysteries ever discovered in the cosmos. Not an explosion, not a violent supernova, not even a blazing, luminous object, but a quiet pull, a slow, persistent tug hidden deep behind the Milky Way's brightest band of stars, a place astronomers call the Great Attractor. You can think of this video as a soft descent, a gentle glide into the kind of cosmic mystery that doesn't demand attention, but quietly earns it. A mystery that doesn't shout, but whispers, because the Great Attractor isn't something we can point a telescope at. It isn't something that shines or flashes. It hides behind a thick curtain of dust and starlight, refusing to show itself clearly. And yet, even if our eyes can't see it, our entire galaxy can feel it. Right now, as you listen, the Milky Way is moving, hundreds of kilometers per second, sliding through space toward a place no one has ever seen directly. Not because it wants to, but because something enormous, something quiet, something unseen is tugging on everything around us. And somehow, that slow drift, that gentle cosmic motion, feels strangely comforting, because while our everyday lives rush, collide, and demand attention, the universe does the opposite. It moves on timescales so long that even calling them slow feels too fast. Galaxies glide like drifting snowflakes. Clusters pull and sway like ancient tides, and all of it happens with a patience so vast. It makes every worry in the world feel small enough to set aside for a moment. So tonight, you don't have to think too hard. You don't have to remember details. This isn't a science class. It's a gentle place to wander, a soft space to breathe, a journey meant to carry you closer to rest than to answers. If you'd like, you can share where you're listening from. I always find it comforting that, while these cosmic structures stretch across hundreds of millions of light years, we are sharing this exact moment together. And if this peaceful trip into the deep universe helps you unwind, helps you drift, helps you breathe just a little more gently, feel free to like or subscribe. It's a small gesture with a quiet ripple, helping this little sanctuary reach someone else who might need a night of soft wonder. But for now, let your shoulders relax, let your thoughts loosen, and let's begin this slow, soothing journey into the hidden force pulling everything around us. The silent, mysterious Great Attractor. Chapter 1, The Silent Drift of Our Galaxy. If you could step outside the Milky Way for just a moment, not in a rocket, not in some futuristic spacecraft, but simply as a quiet observer floating in the darkness, you would see something strange about our home galaxy. It spins, yes. Its spiral arms curl like brush strokes of starlight, yes. But the Milky Way is not sitting still in space. It's moving, gliding, sliding through an invisible current, not upward, not downward, but sideways, toward a region of the sky that looks deceptively ordinary to the naked eye, a patch of darkness behind the Milky Way's brightest band, so crowded with dust and stars that most telescopes avoid it like a visual blind spot. Yet it's in that direction that the Milky Way is traveling at over 600 kilometers per second, Imagine that for a second, while you're resting, breathing, letting your thoughts soften. Everything around you, our sun, the planets, the clouds of interstellar dust, is quietly drifting through space at unimaginable speed, carried along by a gravitational pull we cannot see. Astronomers call this movement a peculiar velocity. Peculiar, not because it's strange in a dramatic way, but because it's the part of our motion that cannot be explained by the ordinary expansion of the universe. Space is stretching, yes, but we're also being pulled. It's a bit like sitting in a boat on an ocean you barely realize is moving. The surface seems calm. The stars reflected on the water look still, but somewhere far below, a faint underwater current tugs at the hull, guiding your drift whether you're aware of it or not. This cosmic drift is gentle on human timescales, far too slow to feel, far too subtle to notice. But on cosmic scales, it's enormous. Entire clusters of galaxies move alongside us in the same direction, as if something ahead were calling them inward. But what is it? A giant object? A monstrous black hole? A supercluster unlike anything we've ever seen? The truth is more mysterious. We don't see anything there. The region is buried behind the zone of avoidance, a thick curtain of dust that blocks ordinary light. So for decades, all astronomers had to rely on was the motion itself, the slow, patient drift of galaxies, like leaves tracing out the shape of a river you cannot see, revealing the current beneath. As more measurements were taken, the drift became clearer. It pointed to the same place every time, a gravitational basin deep within the large-scale structure of the universe. Not a single point, not a single object, but a region, vast, hidden, and quietly powerful. This region would eventually be named the Great Attractor, and what makes it fascinating is not just its magnitude, but the silence of it. No roar of cosmic violence, no brilliant beacon, just a soft, steady tug, imperceptible moment to moment, yet inescapable over millions of years. Tonight, as we drift deeper into this story, you can imagine yourself being carried along with the Milky Way itself, not rushing, not racing, but gliding gently through the dark, following the same invisible pull as billions of stars around you, a quiet cosmic current, leading us toward a mystery hidden behind our own galactic veil. Chapter 2: The Galaxy Ocean Beneath Us. To understand the Great Attractor, you have to imagine the universe not as a vast emptiness, but as a deep ocean, an ocean made of gravity. Most of us grow up picturing galaxies as lonely islands floating in space, beautiful, isolated, separate. The truth is far more intricate. Galaxies don't drift alone. They form clusters, and clusters connect into filaments, and filaments curl around enormous voids, creating a cosmic web that spans the entire universe. If you could see that web, if your eyes could detect gravity itself, you would see long rivers of galaxies stretching across the dark, flowing like glowing threads woven through a tapestry too large for the human mind to hold all at once. Some threads are thin, fragile chains of stars and gas. Others are massive, enormous filaments guiding thousands of galaxies along their gravitational paths. In this web, nothing is ever truly still. Everything is drifting, gliding, following the shape of gravity carved by both visible matter and the much deeper pull of dark matter. In this ocean-like landscape, the Milky Way is not floating freely. It's caught in a gentle current created by the surrounding structure, a current that guides it along one of these filaments toward a deeper gravitational basin. That basin is the region we call the Great Attractor. But before astronomers understood this, they had to unravel a puzzle. Why does our galaxy, along with thousands of others, move sideways relative to the expanding universe? Cosmic expansion pushes everything outward, like dots on an inflating balloon. But peculiar velocities, the sideways motions, suggest something else at work, something massive, something that pulls. When scientists began mapping peculiar velocities, a pattern emerged. Galaxies in our region weren't just drifting randomly. They were all leaning, sliding toward the same area of space. Hydra, Centaurus, Norma Clusters there showed stronger peculiar velocities. Galaxy groups followed the same flow. Even the cosmic microwave background, the oldest light in the universe, revealed that our entire region was moving toward that direction. It was as if a quiet gravitational whirlpool lay hidden in the dark, pulling entire galactic families toward it without ever revealing itself directly. The analogy of an ocean becomes even more fitting when you consider voids. These vast, empty regions act like low-pressure zones. Galaxies near them slip away easily, moving toward denser, heavier regions where gravity pulls together. The Great Attractor sits precisely in one of these heavy regions, at the center of a thick network of clusters and dark matter, a place where several gravitational flows converge, and yet it remains hidden, not because it's faint, but because the Milky Way itself blocks our view. Dust, gas, millions of stars. Together they create a curtain across the sky, preventing us from seeing what lies behind. So instead of observing the structure directly, astronomers read the universe by its movements, the way one might read the wind by watching the sway of leaves, or understand the shape of the sea by the paths of boats drifting upon it. Motion becomes the language, gravity becomes the storyteller, and the story it tells us is this: we are not drifting at random. We are sliding along a vast cosmic current, drawn into a gravitational basin formed by a collection of hidden structures, a quiet pull, a slow convergence, a mystery unraveled not by sight, but by the gentle drift of galaxies through an invisible sea. Chapter 3: Behind the Curtain of the Milky Way. For a long time, the search for the Great Attractor ran into a very human problem. We were looking in the right direction, but our own galaxy kept getting in the way. The Zone of Avoidance, a beautifully poetic but frustrating name, refers to the band of sky where the Milky Way appears brightest, a region dense with stars, dust, and glowing clouds that scatter light like fog around a street lamp. To optical telescopes, this region is almost impenetrable. It shines too brightly, blocks too much, and makes it nearly impossible to distinguish distant galaxies behind it. For decades, astronomers treated the Zone of Avoidance like a blindfold. They assumed very little of importance lay behind it. It was simply too hard to study, so most sky maps left it blank, a silent void drawn not because space was empty, but because our tools were limited. And yet, peculiar velocity measurements pointed straight into this forbidden zone. If something massive was pulling thousands of galaxies inward, it had to be hiding right there, behind the densest part of our own galaxy. This pushed astronomers to step beyond visible light. Infrared telescopes were first. Infrared light can slip through dust far more easily than visible wavelengths. When infrared surveys scanned the hidden region, the blankness dissolved. Galaxies began to appear, dim, distant, but undeniably real. Then came radio telescopes. Neutral hydrogen gas emits at 21 centimeters, a radio wavelength that dust cannot block. Suddenly, entire galaxies invisible to the eye became detectable. Their velocities could be measured, their motions added to the gravitational map, and then X-ray telescopes joined the search, revealing hot gas trapped inside massive clusters. These clusters were invisible in visible light, but in X-rays they glowed like faint lanterns in a fog. Piece by piece, the blindfold fell away. What lay behind the zone of avoidance was not emptiness, but a hidden section of the cosmic web, a continuation of the same filaments seen elsewhere in the universe. And in the heart of that hidden sector, astronomers found the Norma Cluster. Norma is enormous, compact, dense, a gravitational anchor heavy enough to explain a significant portion of the drift. Its discovery was a turning point, proof that the Great Attractor wasn't a mere mathematical artifact, but a real, physical region filled with mass. Yet even Norma wasn't the full answer. Because galaxies beyond Norma kept moving, they flowed past it as though another, even deeper gravitational basin lay farther ahead. Later discoveries confirmed this. The Great Attractor is not a destination, but a midpoint, a ridge on a long gravitational slope that continues toward the Shapley supercluster. Together, these regions form a layered gravitational environment, far larger than astronomers initially imagined. And through all of it, our galaxy drifts quietly, pulled along paths we can only map indirectly, moving toward a place hidden behind our own starlit curtain. A reminder that the universe reveals itself not with bright lights or dramatic shapes, but with gentle, patient motion, the silent choreography of billions of stars responding to forces older than time. Chapter 4: The Hidden Drift of Galaxies. To truly understand the scale of the Great Attractor, we have to step back not just from the Milky Way, but from the entire region of space we call home. When astronomers first noticed something unusual, it wasn't because of a bright object or a sudden flare of light. There was no beacon calling for attention. Instead, the clue came from the movements of galaxies, tiny deviations that quietly whispered that something enormous was shaping their paths. Imagine watching a flock of birds from far away. You can't hear them. You can't see each individual feather, but you can watch the group move, tilting slightly in one direction, curving gently in another. Even if you cannot see the wind itself, the birds reveal its presence through their coordinated drift. Galaxies behave the same way. Their motions, far too slow for humans to see in real time, can be measured through the light they emit. Light stretches when a galaxy moves away, creating a redshift. It compresses slightly when a galaxy moves toward us, creating a blue shift. These tiny shifts reveal the direction and speed of cosmic motion. When astronomers gathered enough of these measurements, a pattern appeared, a clear, consistent flow across vast regions of the universe. Galaxies were not simply spreading out from a central point, as cosmic expansion predicts. They were also sliding sideways, leaning toward the same region in space. This sideways motion is what scientists call peculiar velocity, the extra drift on top of the universe's expansion. And in this case, the peculiar velocity wasn't small. It wasn't random. It wasn't isolated. Thousands of galaxies, from small spirals to giant ellipticals, from our neighboring clusters to those far beyond, were all drifting toward the same direction. The flow became so clear that astronomers began calling it the hidden drift. What made this drift so compelling was not just its existence, but its scale. Local gravitational influences, like the pull from the Virgo cluster or the Hydra Centaurus region, were not enough to explain the speed and direction of the motion. Something much larger was at play. And yet, when telescopes scanned that direction, they saw almost nothing. Just the crowded glow of the Milky Way's midplane, a bright band that hid the stars behind it, like a curtain across the stage of the universe. This mismatch, a strong gravitational pull coming from a region that appeared visually empty, became one of the great mysteries of modern cosmology. So astronomers expanded their search. They looked for patterns in the cosmic microwave background, the faint afterglow of the Big Bang. This ancient light carries a subtle dipole signal, revealing that the Milky Way, the solar system, and even Earth itself are all moving together through space at hundreds of kilometers per second in the same direction pointed to by galaxy flows. This was independent confirmation that something enormous lay ahead. And then came deeper surveys. Infrared, radio, X-ray, gravity mapping algorithms, and simulations of dark matter flows. Each tool added a piece to the puzzle. Each galaxy's unusual motion added another clue. The hidden drift wasn't an illusion. It wasn't noise in the data. It was real, a gravitational signature etched into the motion of the cosmos itself. What makes this revelation so soothing, almost grounding, is the timescale it unfolds on. Nothing here is sudden. Nothing is violent. Galaxies drift like slow glaciers in the night, moving through an ocean of gravity shaped by forces older than stars. And as we look closer, the flow grows clearer, the path more defined, the story more delicate and intricate than anyone first imagined. A story written not in light, but in motion. Tonight, we follow that story deeper, as we uncover not just the drift itself, but the gravitational tug-of-war that shapes the entire region of space we call our cosmic home. Chapter 5: The Great Cosmic Tug-of-War. To imagine the universe at this scale, you have to let go of the small, tidy picture we humans instinctively carry in our minds. The universe is not a simple arena where objects sit quietly in fixed positions. Instead, it is a landscape of competing forces, a vast gravitational tug-of-war that stretches across hundreds of millions of light years. Every cluster pulls, every filament tugs, every void releases its grip, and galaxies, including our own, move according to the combined influence of all these pushes and pulls. When astronomers began tracing the hidden drift, they discovered something striking. The Milky Way is caught between several enormous gravitational players. To the north lies the Virgo cluster, our nearest massive neighbor, a gravitational giant, but not strong enough to account for our sideways glide. To the south lies the Hydra Centaurus supercluster, a dense region with multiple galaxy clusters, exerting a powerful pull. Then, deeper still, Hidden behind the Milky Way's glowing band is the Norma Cluster, dense and compact, sitting at the core of the region we call the Great Attractor. You might expect that with so many gravitational influences, their forces would cancel each other out, like several ropes being pulled in opposite directions. But that's not what happens. Instead, their combined pulls line up in a way that reinforces the direction of motion. It's as if all the ropes, though tugged by different hands, ultimately angle toward the same direction, toward the Great Attractor. But even that isn't the full story, because beyond the Great Attractor, farther along the same trajectory, lies something even more massive, the Shapley supercluster. Shapley is one of the heaviest known structures in the nearby universe, containing dozens of galaxy clusters, each with their own dark matter halos, and millions of billions of stars. When Shapley's gravitational contribution is added, the entire picture changes. The flow of galaxies no longer looks like a local anomaly, a strange current in an otherwise calm ocean. Instead, it reveals a gentle decline into a massive gravitational valley that stretches across hundreds of millions of light years. This valley is shaped by dark matter, vast halos extending far beyond the visible galaxies. Dark matter does not shine or glow, but its gravitational influence is unmistakable. It forms the invisible backbone of the universe, the scaffolding upon which all galaxies sit. In this quiet tug of war, dark matter plays the role of the deep ocean floor. We never see it directly, but we see the waves, we see the currents, we see the drift. And the drift points toward the Great Attractor, not because it's the final destination, but because it sits along the slope, a ridge on the way to the deeper gravitational well of Shapley. In a sense, our cosmic journey is not toward one place, but along a path, a slow, ancient descent carved by gravity over billions of years. There's something calming about that, knowing that our galaxy isn't flying through chaos, but drifting along a gentle gravitational gradient, shaped by structures far older and larger than we can imagine. A slow fall, a cosmic glide, a journey through a universe that whispers its secrets not through light, but through motion. And at the center of this gravitational landscape lies something even grander, a structure so large that it redefines what we consider home. Chapter 6, Laniakea, the immense home of the Milky Way. The more astronomers mapped the hidden drift, the more they realized that the Great Attractor wasn't an isolated feature at all. It was part of a much larger structure, one so immense, so interconnected, that it reshaped our understanding of where we truly belong in the universe. This structure is called Laniakea, a Hawaiian word meaning immeasurable heaven, a fitting name because Laniakea is not a cluster, not a group, not even a traditional supercluster. It is a flow-defined supercluster, a region of space where galaxies move together, all drifting along gravitational pathways toward the same central basin. Instead of drawing boundaries based on brightness or density, astronomers mapped the direction in which galaxies drift, and when they followed those flows, a breathtaking shape emerged. Rivers of galaxies, like glowing threads, flowed inward from all sides toward a region near the Great Attractor. Galaxies that drifted toward Virgo, toward Hydra, toward Centaurus, were all ultimately pulled deeper, toward the same gravitational center. Everything within that boundary, everything following that flow, belonged to Laniakea. That includes the Milky Way, the local group, the Virgo cluster, Hydra, Centaurus, Norma, and tens of thousands of other galaxies. But the Milky Way is not near the center. We sit on the outskirts, far from the deepest part of the gravitational basin. Our galaxy drifts inward, but gently, like a leaf floating near the edges of a vast, slow-moving whirlpool. Inside Laniakea, gravity forms a soft bowl, a shallow valley sculpted by dark matter, visible matter, and ancient structures that formed billions of years ago. The Great Attractor lies near the heart of this valley, a ridge that galaxies flow across, before continuing deeper toward the Shapley supercluster. Understanding Laniakea changes everything about our sense of scale. It stretches across 520 million light years and contains more than 100,000 galaxies. And yet, it is only one region within the even larger cosmic web, one basin among many, one flow among countless flows that shape the universe. There is something peaceful in this realization. We are not adrift in a chaotic void. We are part of a structure, a vast, interconnected, gravitationally sculpted home. A home defined not by walls or boundaries, but by motion, by the gentle drift of entire galaxies toward a shared gravitational destiny. In the quiet of the night, when you think of the Great Attractor pulling our galaxy through the darkness, you can picture it not as a monster, not as a threat, but as a soft gravitational current, one thread in the immeasurable, ancient tapestry of Laniakea. Chapter 7, Dark Matter, the quiet sculptor of the cosmos. If the visible universe is a painting, a swirl of stars, gas, and glowing clouds, then dark matter is the canvas beneath it, silent, invisible, but absolutely essential. For decades, astronomers struggled to understand how structures like galaxy clusters, superclusters, and especially gravitational basins like the Great Attractor could exist at all. The visible matter simply wasn't enough. There weren't enough stars, not enough gas, not enough glowing galaxies to account for the gravitational pull they observed. Something else had to be there, something with mass, but without light. This invisible mass became known as dark matter, not because it is sinister, but because it does not shine, does not reflect, does not interact with light in any way we can see. Its presence is known only through its gravity, its quiet pull on everything around it. The Great Attractor is one of the clearest examples of dark matter's quiet, unstoppable influence. When astronomers tried to calculate the gravitational pull required to drag entire clusters sideways through space, the numbers were astonishing. No known objects, no visible mass, no collection of galaxies seen through optical surveys came close to explaining the strength of the drift. But when dark matter was added to the models, not a little, but vast oceans of it, everything fell into place. Galaxies began to move in the simulations, exactly the way they did in real observations. Peculiar velocities matched, flow lines curved in the right directions. The gravitational basin deepened to the depth needed to explain the pull we experience. It was as if someone had turned on gravity in the places where light could not go. Dark matter halos, the enormous, invisible spheres surrounding clusters, turned out to be the main architects of the cosmic web, not the galaxies, not the gas, but the silent mass holding everything together. These halos form long, interconnected filaments, stretching across millions of light years. Galaxies cling to them like fireflies resting on the thin branches of a colossal tree. The Milky Way sits inside one of these halos, connected to the Virgo cluster through a dark matter-rich filament. That filament connects to Hydra. Hydra connects to Centaurus. Centaurus connects to Norma, and Norma connects to the larger dark matter vein, stretching toward the Shapley supercluster. It is through these filaments that the Great Attractor exerts its pull. Dark matter doesn't rush or collide like ordinary matter. It forms a stable, slow-shifting backbone that changes only over billions of years. The flow we follow is not chaotic. It is patient, ancient, guided by mass we cannot see, shaping the universe like a soft gravitational tide. And perhaps the most calming realization of all is this: we drift through the universe, inside a structure too vast to comprehend, carried along by forces too gentle to feel, held within an invisible architecture that has existed since long before the first stars were born. Dark matter doesn't glow, it doesn't speak, but in its silence, it tells the most profound story of all, the story of how the universe is shaped and how galaxies, including our own, find their path through the darkness. Chapter 8: The Zone of Avoidance, a Cosmic Blindfold. For much of human history, we studied the universe the way someone studies a landscape, through a fogged window, seeing shapes, color, motion, but missing the intricate details hidden behind the blur. The great mystery of the Great Attractor was delayed not by distance, not by faintness, not by the limits of technology, but by something astonishingly simple. Our own galaxy was in the way. The Milky Way is beautiful. Its dense band of stars arcs across the night sky, glowing softly with ancient light. But beauty comes with obstacles. That glowing band contains thick clouds of dust, rivers of molecular gas, millions of stars bright enough to drown out anything behind them. Together, they form what astronomers call the Zone of Avoidance, a region of the sky so crowded, so bright, so heavily obscured that optical telescopes simply cannot peer through it. Imagine trying to look through a brilliantly lit fog. No matter how bright the flashlight you shine, you cannot see what lies behind. For decades, astronomers simply left this region blank on their maps, assuming nothing important was back there. Because if something important were hiding there, surely we would have seen some trace of it. But as the data on peculiar velocities grew stronger, the universe whispered a different truth. The gravitational pull was coming from that very blind spot. And so began one of the most creative chapters in observational astronomy. Scientists had to find ways to see the unseeable. They turned to infrared, which slips through dust more easily than visible light. Infrared surveys revealed faint smudges, galaxies lurking behind the Milky Way's bright curtain. Then came radio observations. Hydrogen gas emits radio waves that dust cannot block. Suddenly, entire hidden galaxies appeared, their motions traceable through Doppler shifts. Next were X-ray telescopes, which detected the hot gas trapped in massive clusters. These clusters, invisible in optical wavelengths, glowed like soft lanterns in the X-ray sky. piece by piece, the zone of avoidance dissolved. The blank space on cosmic maps came alive with structure, clusters, filaments, and immense gravitational anchors. And at the heart of that hidden region, astronomers discovered the Norma Cluster, one of the most massive nearby clusters we had somehow missed for decades. Norma's presence changed the entire gravitational landscape. It was exactly the kind of structure capable of producing the mysterious pull we felt. But then came the twist. Even with Norma included, the numbers still didn't add up. The pull was too strong, the drift too deep. Something bigger still lay beyond, and so the story expanded past the zone of avoidance toward deeper structures like the Shapley supercluster, revealing that the Great Attractor wasn't a single gravitational monster, but the beginning of a much larger cosmic descent, a gravitational slope masquerading as a mystery, hidden only because our galaxy's starlight shone a little too brightly across the sky. In the end, the zone of avoidance wasn't a barrier of distance, but a reminder that the universe often hides its secrets, not in darkness, but in light. Chapter 9: The Cosmic Web and the Shape of Our Journey. As astronomers stepped back and looked at all the data together, the hidden drift, the zone of avoidance, the Norma Cluster, the pull from Hydra Centaurus, and the deeper tug from the Shapley supercluster, a larger picture emerged, a picture not drawn by light, but by motion. Galaxies were not just objects moving randomly in space. They were moving along pathways, curving, sweeping lanes carved by gravity, like gentle slopes leading into valleys, on a landscape too large to see in a single glance. This landscape is known as the cosmic web, a vast network of filaments, clusters too, superclusters, and enormous voids that stretch across the universe like frozen rivers and canyons of gravity. The cosmic web is not static, it is dynamic. It grows and evolves over billions of years, and everything within it, stars, galaxies, clusters, moves along the gravitational contours sculpted by dark matter. When scientists mapped the direction of peculiar velocities, they were not just measuring motion, they were tracing the outline of this invisible web. The Milky Way sits on one of these filaments, a thin, delicate bridge of matter connecting us to larger structures. That filament connects to Virgo, Virgo to Hydra, Hydra to Centaurus, Centaurus to Norma, and Norma to Shapley. It is along this filament that our galaxy drifts through space, following the gravitational gradient. As naturally as water flows downhill, this means something profound. The Great Attractor is not pulling us like a magnet. We are simply moving along the structure of the cosmic web, sliding through an ancient gravitational valley, carved long ago by dark matter and early cosmic evolution. The flow we follow is part of a larger pattern called Laniakea, the supercluster we truly belong to. But beyond Laniakea lie other superclusters, other gravitational basins, other flows that shape an even broader cosmic geography. In this view, the universe becomes less like a random scattering of dots and more like an intricate, interconnected system, alive with structure, alive with motion, alive with a harmony so subtle you only notice it when you step back far enough. And perhaps the most soothing truth of all is this: we are not lost in the universe. We are not drifting aimlessly. We are following a quiet, ancient path. woven into the very fabric of reality, a gentle descent into deeper and deeper layers of the cosmic web's gravitational artistry, a journey shaped not by chaos, but by the elegant, silent pull of structures so large that no human mind can fully imagine their scale. Tonight, as you let your breath settle and your thoughts soften, you can picture the Milky Way, not as a lone wanderer, but as part of a flowing river of galaxies, moving through the darkness, in a cosmic rhythm older than time, guided by a gravitational landscape that stretches far beyond anything we can see. Chapter 10: The Great Attractor, not a place, but a pathway. For many years, the Great Attractor was imagined as a thing, a massive object, a gravitational monster, a single point in space so heavy that it dragged galaxies toward it, even entire clusters and superclusters. But as astronomers gathered more measurements, as they mapped peculiar velocities, as they pierced deeper into the zone of avoidance and traced the cosmic web with greater detail, a surprising truth emerged. The Great Attractor is not truly a destination. It is a region along a much larger gravitational slope. In the early days of its discovery, scientists assumed the flow of galaxies would stop at the Great Attractor, that galaxies were plunging into it, like water falling into a drain. But that's not what the data showed. Galaxies didn't slow down when they reached the Great Attractor. They didn't cluster around it. They didn't form a dense knot of matter collapsing inward. Instead, they kept going. They moved past the Great Attractor, continuing deeper into the Hydra Centaurus region, and ultimately toward a far more massive location, the Shapley supercluster. The Great Attractor wasn't the bottom of a gravitational well. It was the midpoint of a long descent, a ridge, a bend in the road, a place where the flows converge briefly before continuing on their deeper journey. This realization changed everything. The Great Attractor wasn't a monster after all. It was a marker, a signpost along an ancient gravitational highway that began forming billions of years ago when dark matter first sculpted the cosmic web. The pull we feel now is not something new. It is the ongoing motion of our galaxy along a filament that stretches across hundreds of millions of light years. When you look at the sky, the Great Attractor appears hidden, invisible, mysterious. But in the gravitational landscape, it is simply one slope on a vast cosmic hillside. Picture a leaf floating down a slow, quiet river. As it passes a bend, it briefly changes direction, not because the bend pulls it, but because the river flows that way. The Great Attractor is that bend, not the cause of the motion, but the shape through which motion must pass. This is why galaxies feel its influence, even though we cannot see it. It is not a beacon. It is not an object. It is a section of the river, a pathway carved by gravity. When dark matter simulations are run with precise models, the flow becomes beautifully clear. Galaxies in our region slide gently down a gravitational slope from the Virgo side toward Hydra, across Centaurus, through the Norma region, and onward toward Shapley. The Great Attractor is simply the midpoint of that slope, a gravitational gateway, and in that understanding, there is something deeply soothing. The universe is not pulling us violently. It is guiding us gently. We are drifting along a pathway, older than stars, older than galaxies, older than everything we know, a quiet descent along a cosmic landscape we are only just beginning to see. Chapter 11, Shapley, the deeper destination beyond the Great Attractor. If the Great Attractor is a quiet bend in the river, then the Shapley supercluster is the deep basin into which the river flows. Shapley is enormous, one of the most massive structures in the nearby universe, a colossal collection of galaxy clusters, rich in dark matter, rich in hot X-ray gas, and powerful enough to tug on entire regions of space. When astronomers first measured peculiar velocities, the Great Attractor seemed to be the answer. But even after Norma and Hydra Centaurus were included, the numbers didn't balance. The pull was too strong, the drift too deep, the flow too continuous. Then, farther along the same line of motion, they found it. Shapley. The Shapley supercluster contains at least 25 massive galaxy clusters, each the size of Virgo or larger, and hundreds of smaller groups. Together, they form a gravitational titan, far outweighing anything else in the surrounding universe. In the map of cosmic flows, Shapley sits at the bottom of a gravitational valley, a basin into which galaxies drift over hundreds of millions of years. This is why galaxies do not stop at the Great Attractor. They pass through it. They slide past Norma. They glide beyond Hydra and Centaurus, all because the true gravitational low point is much deeper, much heavier, much more massive. Shapley is not hidden like the Great Attractor. It sits beyond the zone of avoidance, visible in optical wavelengths and blazing in X-ray surveys with the glow of hot intercluster gas. But even so, its full scale was not recognized at first. Only when astronomers traced the motion of galaxies far beyond our region did they realize that Shapley was not merely large, it was dominant. It is the reason the Great Attractor exists as a ridge. It is the reason the Hydra-Centaurus region is so dense. It is the reason our galaxy drifts in the direction it does. Shapley is the gravitational anchor that shapes the entire flow of Laniakea. But here is the gentle, surprising truth. Even Shapley is not the end of the story. Beyond Shapley lie even larger superclusters. Beyond those lie even deeper gravitational valleys. The cosmic web stretches farther than any single structure can define. Our drift toward Shapley is just one movement in the slow cosmic dance of gravitational tides sweeping across the universe. No collision awaits us, no sudden pull. The timescales are too vast, the motions too gentle. Shapley is not a destination, but part of a flow, a quiet gravitational tide. We surf across billions of years. As you breathe slowly, letting the quiet of the night settle around you, imagine the Milky Way gliding down a gentle cosmic slope, passing through regions shaped by dark matter and ancient clusters, moving toward Shapley with a patience only the universe can hold. A drift so slow you could live 100 million lifetimes and never notice the motion. And yet, on cosmic scales, the motion is everything. Chapter 12, What It Means for Us, a quiet journey through the universe. After exploring the Great Attractor and following the river of galaxies toward Shapley, it's natural to wonder, what does all of this mean for us? For the Milky Way? For life on Earth? The answer is both simple and deeply comforting. It means we are part of something vast, a quiet cosmic migration, stretching across hundreds of millions of light years. Our galaxy is not isolated. It is connected, woven into a structure larger than our minds can hold, guided by gravitational currents, carved long before the sun was born. Every star you see in the night sky, every nebula, every cluster, every glowing filament is drifting along these same pathways, following the same gentle gravitational slopes. We are travelers, not through chaos, but through structure. The cosmic web defines the flow, dark matter shapes the valleys, superclusters form the ridges and bends, and inside that web, the Milky Way moves naturally, peacefully, without urgency. It will never crash into the Great Attractor. It will never be torn apart. The scale of motion is so vast that even though we move at hundreds of kilometers per second, the journey is smoother than still water. Billions of years pass between the changes that truly matter. Entire civilizations could rise and fall without ever noticing the drift. This is perhaps the most soothing truth of all. We live in a universe that moves with a slow, ancient rhythm, a rhythm so gentle that even as entire clusters slide through space, you and I feel nothing at all. No vibrations, no tremors, no tug, just the quiet continuity of existence in a cosmos that unfolds at its own pace. Understanding the Great Attractor does not bring fear. It brings perspective. It reminds us that we are held in place by gravity older than time. We are part of a structure too elegant to fully see. Our galaxy moves with millions of others. The universe is not chaotic. It is deeply, profoundly connected, and in that connection, there is peace. As your breath falls into its gentle rhythm and your thoughts begin to soften, you can imagine the Milky Way gliding through the dark, a small island of starlight, drifting calmly through a universe shaped by invisible hands. No rush, no danger, just the long, slow journey of a galaxy wrapped in stars, floating along a quiet gravitational stream toward destinations so distant that even time itself seems to whisper. And that is where we leave the Great Attractor tonight, not as a monster, not as a threat, but as a gentle curve on the path our galaxy has been following since the dawn of creation.